You will learn step by step how to create a simple image processing application using C++ and Qt. If you're unfamiliar with Qt or Qt, it is a very popular tool to design applications for both desktop and mobile. It's used in robotics, embedded systems, and is also compatible with C++ and Python. You can do all sorts of applications with it, especially for things like infotainment systems or a kind of a user interface for an autopilot design. And that is why, especially for avionics, it is often used. Let's begin by creating a new project. I will give it a name and save it in my desktop folder. So let's make a Qt widgets application. I will call it image processing and save it inside just a random folder on my machine. Once you specify a name, leave every other setting the same, the build system and the other compiler options, especially main window here. This should all configured automatically based on your machine installation of Qt. So when you press start, you will be redirected to this window here where you can see all the files of your application along with the play button on the bottom left. So here is the main file. This one will be the same. It just launches the window. Main window is where all of your code will go here because we are building a single page application. So in the project file .pro, we can see all the files that are included. And here is where our code will be done. We aren't going to open any more windows from this one. This is a header file where you include any methods and classes definitions. So this is the UI file. This is where you will actually drag and drop objects, and Qt lets you very simply define widgets and other UI elements that you might need. We'll be using labels for the most part and a push button along with the Q file dialog, which you'll see after. So initially we have this window here. Let's go on the bottom right and set the size dimensions to whatever you want, so that when we drag it, it'll be fixed to a maximum size. The first thing we'll do is include a push button. Let's drag and drop that and call it browse, and also set the sizing of it. You can set the width and the height on the bottom right. Let's change the text and make it a bit bigger. Now let's drag in a label. So a label lets you define text on your screen. So I'll call this one load your image. Now each label can be given a name because it is part of the UI. So if you want to change the name in code, you can also do that. So let's just make the size bigger and make it fit better on the screen. So on the right, you see that the labels have a name and the object. So that's where you can actually edit that. So let's drag in another label and let's make it bigger. This is where our picture will go. When we load the image onto the screen, we want to actually display it here and remove the text which is in there. Also give a maximum size to it so that when you drag it, it'll lock at its maximum size. Let's drag in more labels. I'll call this one image information. So the information we want to display is the image width, the image height, the number of blobs, and the occupancy percentage. So like how much of the image is dark. So we can drag in labels for all that. So I'm just copying and pasting it here. You can actually do this very quickly by just copying because it's very intuitive. So initially we don't have any dimensions, right? Because we don't have an image. So we can specify placeholder values for that. So let's put zeros for everything. And in code, when we actually load the image, we will change this text here. So I'm just setting my size limits for all these labels because I don't want them too big. It's good practice to do it. On the bottom right, as you can see. Now each label will have a name. So where it says object, you can actually change the name of the label itself. Where it says object name. So let's do it for all of them. You can give them any name you want, but just keep track of what they are, because when you get to the code, you will actually use those object names and change their text fields when you actually scan the image and process it. So I would recommend maybe when you give them a name, just like copy and paste a screenshot of it into like Paint or somewhere so you can keep track of it. You can always go back to this window and check the name of the label that you want to use. Also, giving a name is very important because let's say if you're building a large application, you don't want to lose track of the labels you have and the UI elements, so it's good practice. Okay, so when we're done, we can build with the play button and you see how the UI opens up. It looks pretty good. And we don't have any functionality yet because we just put the elements in there. So now let's start with that. Now let's add functionality to the push button. So go in the UI page, right click the button, press go to slot, and then select clicked. So when we click this button, you want to activate this method here, which will create on its own. So write this here, qstring file name equals qfile dialog, open this, q directory home path and images. Because we want to open a file, we need to include a few things here, so let's include all that first. Everything we need for our application: qfile dialog, qmessagebox, qpixmap, qimage, qvector, and a qq. Now a vector in C++, as you all know, is for arrays and queues. Queue is also a data structure, so in Qt you have the qvector and the qq. It's a bit different, but they work the exact same way. And I'll show you how to use them after. So yeah, qstring is our file name itself. Then let's actually process this file. So we say if the file name is not empty, we have selected a file. I'm just going to put a comment above this method so that we know what it does. So I'll say read and process the image. So if the file name is not empty, we want to get the image from the file. So write qmessagebox information this file name, it'll open an alert, and then create a q image with that file name. And then you have to get the pixel map, so all the pixels in the image. So write qpixmap from image and then image in the brackets there. So image img, that's your variable which contains the image defined by the file name, and then you get the pixmap of it, and that'll be stored in pix. So when we have this image, we want to actually process it now. So in the UI, we want to load it into this label here. So I call that label, I'm going to call it label underscore pick. Go back to your main window class and let's now get the label dimensions. So label underscore pick was our label name in the UI. So let's get the width and the height of it by calling it like this, int width and int height. You will see this error because we didn't build our application, but when you build it, it'll go away. And then you load the image onto the pixmap like this. You scale it and then you load it on there. So if you test it now, browse and load the image, you see how it loads on, so that looks good. And it's scaled up appropriately. So we use the keep aspect ratio method to scale it to fit the label. Okay, now we can get the image width and the height. Create an empty matrix because we'll be using this for image processing. So we can write unsigned integers, columns and rows for the image width and the height. I'm using unsigned int because it's obviously positive, it can be negative, and unsigned is that data type. We also have the number of black pixels that are 0, and I created an empty vector like this, a 2D array with rows and columns, where you can actually initialize it with zeros at the start and then fill it in as you go along processing the image. So this is how you define an empty vector in 2D. of a fixed size in C++. If you have used vector in the past, it's the same logic. I'm just using qvector instead. Okay, let's get the pixel data and update that binary matrix called image array. So let's create two for loops. We want to iterate each pixel in the image, so I rows and then j columns. So I'm just going to copy and paste it to save time. So each pixel element will be represented by j comma I because it's columns and then the rows. X is the column, Y is the row. This might be a bit tricky, but just keep it in mind that when you select in Qt, it's X and Y, so columns and rows. If you do Y and X, it'll give you an error saying out of bounds, unless it is a square image, but yeah, just keep it X and Y, so j comma I. You get CLR current is the Q color. And since each pixel will have an RGB, red, green, and blue, we can call it like this: int R, int G, and then int B, along with int A for alpha. So a pixel is RGBA, red, green, blue, alpha. If it's a dark pixel, then red, green, and blue will be almost 0, and alpha will be a very high value. So we want to actually recognize this. If it is a dark pixel, we assign it to the array as a value of 1 because 1 represents a dark here, and then 0 is white. So I'm just going to write this if statement there saying if the RGB value sums to a very low number and the alpha is very high, more than 240, then it is practically a dark pixel, and we can assign it like this: image array ij is equal to 1, and we also increment the number of black pixels by 1 because we want to get how many of them are in the image as opposed to the total area. So that's how you do that here. So now we can store this image array to a file. Now this is if you want to do it, but it's quite nice to see. So I'm just going to use the Q file output here. Now there's plenty of documentation on this. So I'm just going to write a QString file name and I'll save it to my desktop here. Give the location there. And then I'm going to say Q file out, file name. So file name is my text file here, which I'm going to save the image to. And then I'm going to write if the file is open, and if it is in read-write mode, it normally is. You can always write to a file like this. I'm going to iterate the image and then save each pixel. So I'm going to call a Q text stream called out, and that lets you output text to the file. So I'm just outputting each row and column like this, and then at the end of each column I put a blank line because I want the image to go to the next line, right? I don't want the entire image to be stored in one row, then it's going to look weird. So when you're done each column, you want to jump to the next line so it can output the next row. So I put the end line there at the end of the second internal for loop. So this is how you can actually output image data to the screen. Just putting comments here to make it more clear. Okay, so that concludes the text outputting part. Let's go to the label and output the information on the UI itself. So I'm just going to write UI dimensions. I call it dims, D-I-M-S, in my label on the UI settings. So you have to call that label like this. So write dims set text and then QString from string. Because when you set a label name, you have to use QString. So I'm just converting columns and rows to string and then outputting that. And then that string, I'm making it into a queue string. So for that, the method is called from std string. Std is the C++ standard. So I'm just concatenating my columns and rows, the width and the height, and then outputting that. The width is the columns and the height is the rows, obviously. So I'm just putting a comment there saying the label text must be a queue string. And we can easily get a queue string from a normal string. Let's create another value for the percentage dark. I call it PD. So I'm just casting the integers to a float and then dividing it by the total image size. And then I'm setting that element here. So pdark is my UI label for the percentage dark, as you can see there. And I'm simply setting that text here. So I'm just converting PD to a string and then into a queue string and then outputting that to my UI by doing set text. So by now you have learned how to change the label of a UI widget within Qt. Quite simple. You just write set text and then go from there. Okay, now we are done with getting the image dimensions. Let's test it. Let's build it and load the image here. I made this image in MS Paint. I just put black spots on there and saved it as a PNG file or a JPEG file. That should be okay too. So you see how it updates there. It looks pretty good. We have the occupancy percentage and the width and the height showing there. We also have our text file here. It contains this large array of ones and zeros. Now I'm not going to like scan every element here. I'm just going to look at it briefly and see that you have some ones in there, as you can see, and that corresponds to a dark value. So yeah, it will lag because it's a very large file, but this step is optional. You don't have to do it. I just did it for demonstration purposes. So far our application is looking good, but now we need to do the hard part, which is the image processing. We need to find how many blobs are there and its maximum area. So for that, I'm creating a new method here. So go to the header file .h and then write a new method for image processing. I'm going to be using breadth first search algorithm for this. So we want it to return a vector. So let's do that. QVector, the name is find properties. It takes in an argument image array, which is the 2D array. The second argument is the number of rows, and the third argument is the number of columns. Now you notice I'm putting the ampersand in front of the variables because I want to pass it as pointers. I don't want to make a copy and pass that. I'm passing by reference here. So that's a good benefit. You save time. You don't make a copy of the array and pass it in. You just pass in the array itself. The second method is for the breadth first search. It takes in the number of arguments, the position, which is a QVector, a 2D array called explored, which is the same size as the image array, the number of rows, the columns, and also one more argument there at the end. For the explored, the rows, the columns, and the image array there, once again I'm passing it. They're all pointers because I want to pass it in by reference again, not by value. It's a good practice to do it whenever you can. So with those methods defined, we can now call it. So let's put a comment there saying process the image, find the number of blobs. So you simply define the same thing. You can return it in a vector called results, and then you write this dot find properties, and then you just put the same arguments like image array. We add rows, columns. So you see how it's become italic because it's passing it as a pointer. So it's passing the pointer to it. It's passing by a reference, and that is why in Qt it becomes italic. So that's quite nice. It tells you that it's being passed in by reference by italicizing it. So that's one good benefit of the Qt GUI. It tells you exactly how the variables are passed in different methods. I then update my UI with the results. So I'll just write that here now, but I won't actually do it now because we need to actually do the methods. But first, let's just quickly put this here. So number of blobs, I call it n blobs, and then MB area, I call it for the maximum blob area. So we get those UI elements, and then once again you say set text from string, the results 0 and the results 1. So the results will be a two-size vector. The first element will be the number of blobs, and the second one will be the maximum blob area. I'm just putting in another comment here to keep track of it. It's good to put comments everywhere. It helps you keep track of your code, and when you get back to it after a few days, you won't forget what some variable does. Now we are ready to define the method. So I'm just putting another comment here. Now this method is similar to a lead code question. It's called maximum number of islands and area of island. And I will explain the algorithm now in brief. So the algorithm which I'll be implementing is breadth first search algorithm. You can also find this on LeetCode. It is the question number of islands and maximum area of island, where you have a binary matrix of zeros and ones, and you have to process it to get the number of blobs along with how big the largest one is. So I'll be doing the same implementation here. Now I won't be going into too much of detail about this algorithm. I'll cover it in brief because there are many other videos on this question on LeetCode. So here is a brief explanation of the breadth first search algorithm. Once again, I won't go into too much detail because it's covered in many other videos. So you iterate along the array here, the image array. I'm keeping a track of the explored locations in a vector called explored, which is the same size as the image array. Every time you hit a 1, you explore it using breadth first search, and you add a 1 to the number of islands. And since we are marking the points in the explored array, if you go to another 1 which is a part of the same island, so like the same group of ones, you will not go explore it twice because it's already been visited before. So we just iterate in the array. Once again, the moment you hit a 1, you start the exploration using BFS, or you can also use the depth first search if you want to, and then you mark the island as visited. So you just add a 1 to the number of islands. We keep on doing this until we reach the end of the array. You can also keep track of the explored locations in a 1D array, it doesn't matter. But I just put it in a 2D array because it's more intuitive to understand. You see how at the end, we'll be exploring the ones here, so the zeros which correspond to 1 in the image array will become a 1. And it'll change as you see here. It just looks more visually understandable if I put it into a 2D array. I know in LeetCode some people must have used like dictionaries or hash table to put it, that's fine too. But for me, my best understanding, I did it this way here. Okay, let's go to the method now and let's finish it off. So I'm just going to copy that large method definition there. It's quite big, I know, but gotta do what you gotta do, right? So yeah, let's begin. Let's create some variables: number of islands, maximum area, and then the area explored. So yeah, we start now. So we define the explored 2D array, which is of integer type. It'll be the same size as the image array, rows and columns, and we initialize it with 0. And now we begin our loop. Same idea as before, 2 loops which are nested. So if a 1 is reached and if it is not explored already, we begin the exploration and add 1 to the number of islands. So that's how you check for that method there. And now I'm going to call the position. So You get the position in the integer format because remember I and j are unsigned, so we need to make it a standard integer to pass it into the method. We get the area by returning it from the breadth first search. See how I just put an integer there because it returns that type? So I'm going to copy this whole thing and then put it there. So those are our arguments that we need: the position, the explored, rows, columns, and the image array. And then you just update the maximum area if it is bigger. Because we don't want to keep the track of all the areas, we just want the maximum blob size, so I'm just doing it like this here. Lastly, you just increment the number of islands by 1. So we now have to define our breadth for search. It is not done yet. I'm just making my results vector there. And then I return it from the find properties. Let's put the main window there so it belongs to that class. Just for like the other methods there, so that's it. That's good. Okay, so for breadth first search, let's finish this method here. I'm going to be using a queue for this, and that's why I included my queue at the start. Normally, breadth first search is done with the queue, and if you're using depth first search, it is done with the stack, which is practically the opposite of a queue. So we get the potential moves, so we can go up, down, left, or right. We cannot go diagonally because that doesn't count. So I'm just going to write vectors for that: U, D, L, and R. So it makes sense, right? Like up is, we go -1, the down is 1, left is -1, and right is 1 in the corresponding index. We keep track of the island area, so that's 0 at the start. And we create a queue, so we just write QQ, call it not explored, and then it'll be a queue of integer data type. So it's a queue of vectors here, keep it in mind. Each element in the queue is a vector. We put the position in the queue at the start, so at the front of it. And while the queue is not empty, we loop along. So when the queue becomes empty, we will be done with our exploration and the while loop will exit. The first thing you do is you find the potential moves from the position itself. So I'm going to create a big vector saying potential moves, and then you offset the position by up, down, left, and right, as you see here. It's a vector of vectors. The syntax might look a bit tricky, but each element is a vector of 2 elements because it's an X and Y, right? So I do up, down, left, and right. I'll just put a comment there so you can understand it better and keep track of it after. So we're simply offsetting the position by that. Now we iterate in these moves, and if it's a valid move, we can explore it, but if not, then we just skip that iteration, as you'll see here. Okay, so this is if the move is not valid. We just skip it, and if this if statement doesn't match, then the move is valid, and then we enqueue it. And then we just say add the current position to explored. You just set the value to 1 because it was 0 before. We add the area, we just add 1 to it because every time we explore something, you mark the area too. And each pixel is like 1 area unit, so we just add 1 there. You dequeue it, so you remove the position from the front of the queue. And then you update the position. So you just write position is equal to notexplored.head because you want to make the position the front of the queue. We just do it this way here. I have a second check for if it's not empty because you might have a case where at the end you are still in the while loop, but then it becomes empty because of the dequeue, and then that'll crash the program. So we need to put a second check here, and then we just return the area from that. So that concludes our breadth first search, and we can test our method now. We can test the entire application because that's it for the app itself. So let's do that now. So press build, it should load it. Okay, get your image. Load the image file. Okay, and then that's it. So you see the number of blobs and the maximum blob area. So that's pretty much our application. Quite simple, but quite useful too. There's other videos you can see if you want to deploy it yourself. But yeah, that's it for now. I hope you learned something new. I showed you step by step how to create a simple Qt application for image processing. We covered many concepts, but you can expand on this and create more interesting and more complex things from here. So thanks for watching.